Okay, welcome to the first video for Chapter 5, our last chapter before the final exam. Okay, and yeah, it's coming up that quickly. Okay, so here we go. Chapter 5 is not going to be a real long one. There's only going to be 2 lectures on it. We're doing sections 1 and 2 today. These are the parts that I want you to know. We're dealing with bisectors of angles within triangles. We're dealing with medians, altitudes, and perpendicular bisectors. Your resources here, and trust me, it's important to go through these. The PowerPoints, okay, notes for Chapter 5, Section 1 and 2, those are good. And the notes I've provided with a lot of pictures and explanations. The problem with this section is not the work. The work is going to be really easy. You'll see that in a second. What is difficult is the verbiage, the terminology, the vocab, okay, whatever we want to call it, okay? So it's important that you go through and look at the pictures that I've provided, okay, especially here, okay? A perpendicular bisector does exactly what its name says it does. It's perpendicular to a segment and it cuts it in half, okay? When we are in a triangle, it does something just a little funky. Okay? If we look at this as a triangle now, it creates an isosceles triangle. Because one of the cool things about a perpendicular bisector is every point on that bisector is the same distance from the end point of the segment it's cutting in half. So it can create a lot of different triangles, and that's important because you've got those two are equal to each other, and so are those. Okay? If you have an angle bisector, once again, as the name implies, it bisects, cuts in half, an angle. Okay? But the cool part about this is, if this is bisecting this angle, then every point on that bisector is equidistant from the sides of the angle. And remember, when we measure distance, it's always in a perpendicular segment. So when I do that, those are equal segments. Yeah, that's important. Okay? So if you see this, we know it's a bisector. If you see this, we know those are equal. Okay, we got a lot of converse theorems working here. Median. Think about the median on a highway. It's in the center. That's what a median segment does. It goes from a vertex to the midpoint of the opposite side. There are 3 in every triangle. Vertex to midpoint. Vertex to midpoint. All 3 intersect in the center. Okay? We'll get into that in a second. There's a funky name for that. I'm not really worried about you knowing it, but I want you to understand when you see it, this is what it means. Okay? And finally, altitudes. If you think about altitude, just the word, it's how high up. Well, that's what an altitude is. Altitudes are measured with perpendicular segments. There's a theme here. Follow along. An altitude is perpendicular to the opposite side. Okay? It can be inside the triangle. It can be a part of the triangle. It can be outside the triangle. And you'll see that on obtuse triangles. So, acute triangles, it's going to be inside, and there are 3 of them. They'll all be inside. Okay? From here, perpendicular to here, here, perpendicular to here. Once again, in the notes, more pictures. In a right triangle, the legs, the 2 perpendicular sides, each of those is an altitude. The 3rd altitude is perpendicular to the hypotenuse. When you have an obtuse triangle, you cannot go from here to here and be perpendicular. So it's like if you were standing up here and you dropped a rope, it would go straight down. This is what we call an auxiliary line. It's not part of the triangle. We just draw it in. Because the absolute definition of an altitude is a segment that goes from the vertex to a point perpendicular to the line that contains the opposite side. So if I look at this entire line for that has that side in it, that's what it has to be perpendicular to. So that's the definition in truest form of an altitude. Okay. Questions like you're going to see. Okay. We'll start here and I'll try and get you close enough so you can see them. Okay. Our first one here. We're dealing with, and yes, I stayed with the same color, perpendicular bisectors here. Okay? So, in the first one, it wants you to find what the length of TP is. Well, since that bisected this side, remember we said each point on that bisector is equidistant. So, this side is also 7. Okay? I told you the work isn't that difficult on some of these. Okay, down here, we have a perpendicular bisector. It bisects the side. We want the length of VU. Well, to do that, we have to find the value of x. So, since these are equal segments, that's our equation. Okay? And we're just going to solve for x. Okay, so I solve for x and I find that it's 2. And then I've got to take that and substitute it for that right there, which I'm doing here. 6 plus 10 is 16. Okay, there's that problem. Okay. Our next two problems deal with angle bisectors. Okay, we know it's an angle bisector because it is equidistant from the sides of the angle. So, if I want the measure of angle NJZ, this one right here, I know, oh, because it's an angle bisector, that has to be the same measure. Okay? Down here, once again, these being equal tell me that they are on the bisector. So, that means these two angles are equal to each other. And we're going to solve those much as we did here. So x equals 10, but we want the measure of MFZ. So we have to replace this x with the 10. Okay, so there's those. Okay, now, here's where the vocab I was talking about comes into play. I put these so we would know that they are each perpendicular bisectors here. But the other way we can tell that is this word, circumcenter. The circumcenter in a triangle is where the three perpendicular or side bisectors intersect. Okay? So, we want segments that are going to be equal to each other. Okay? So in this case, BN is going to be congruent to NJ. Yeah, it's that simple. Okay, and then BL, this right here, is going to be equal to this right here and this right here. These are all broken up into proportionate segments. That's the word. Okay? In this case, it's going to be 2/3 to 1/3. We'll get into that in a second. Okay? So, to put that there is congruent to okay, so that's it for the perpendicular segments. Now down here, I use the same thing. I use the purple like we did for the angle bisectors. But here's the other term you need to know. If you see in-center, A is the in-center, that means that's where the three angle bisectors are intersecting. So if we have three angles being bisected, that means this is 21. That means this is 32. Okay, so YLA, we know we've got 32. We already figured that out. YGA. Now this one we have to do a little work for. Okay? This is a 64-degree angle. So I know if I take angle L, angle Y, okay? I already know angle L is 64 degrees. 21 and 21 is 42 degrees. I'm going to add these together and subtract from 180. Okay? That's going to tell me what all of angle G is. Okay? So that's 106 subtracted from 180 is 74. Now this, because the angle was bisected, is half of angle G. Okay? So each of those is 37 degrees. Okay, so bugs. So that's how you solve those. Okay, let's go over to a couple of others. Now these are dealing with medians. Okay, there we go. New section, new paperwork. Okay, so on this, here I'm told right away, oh look, I've got the parts shown as equal to me. So that means that those are midpoints, which means each of those, okay, F, B, C, D, E, A, those are each medians. Okay, so medians cut everything up. Okay, now, the cool thing about the median is each median is divided into 1/3 and 2/3. Watch. If I look at BF, okay, I know it's 39. This is 2/3, this is 1/3. If you can easily divide 39 by 3, which you can, okay, it'll allow you to figure out what each length is. So, 13 and 26. I'm going to work these through here before I even start answering questions, because it'll make life easier. Okay? CP is 30. That's 2/3 right there. So you have to figure out what 30 is 2/3 of. Okay? Okay? So that's what you're dealing with right there. That's how you're going to find the other part of it. Let me just say that in brass tacks for you, okay? So that entire length there is 45, which means that part is 15. And our last one, if EP is 18, okay, that's the short part. We've got to find the other part. So 1/3 of something okay? So now we know the entire length is 54. We subtract. Okay? That's how we get our answers in this situation. And that's gravity at work again. Okay? Stay there. Okay, let's go through and fill out the answers now that we have them up on our triangle. Okay? We want the length of PD right there. Okay. BP. Okay. PA. Okay. FP. Okay. CD, the entire length. Okay, and EA, the entire length right there. Okay? That's how you attack medians and the length of medians. Okay, remember, medians don't say anything about angles. They talk about lengths of segments. Okay, now, in that particular problem, you were given the segments were equal with the little marks. Here's, okay, there's the glare again. There's the word right there. Centroid. The centroid is the intersection of the three medians in a triangle. Okay? So, once you see that word, you know, oh, I have medians. That means those two are equal to each other. These segments are equal to each other. These are equal to each other. Okay? This is 2/3, that's 1/3. 2/3, 1/3, and so on. Okay? So let's fill in what we've got. Okay? I have been given that MZ is 6. YI, the whole length, is 14. Okay? And NZ is 12. Okay? I'm sorry, YI is 18. I was going to say, wait a minute. That didn't look right. Always my greatest problem, transcribing things from the book, right? Okay? So that's the problem. So we've got the whole thing there is 18. So, once again, we're going to figure out what we've got here. The first one is, I'm just going to figure out 18 because I can break 18 down very easily into thirds because it's divisible by 3. So the short segment is going to be 6. Okay, and that means this is going to be 12. Okay? Now, 12 is 1/3 of the entire length. Okay? Okay, so that means the whole thing is 36. So that means this has to be 24. Okay. And we've already got an easy one going here. Okay. 6 is 2/3 of the entire length. Oh, let's use this. Okay. So that means the x, the whole thing is 9. 9 minus 6 is 3. There are all of my segments. Okay? That's how we're going to solve this. So let's go through. Okay, ZR is here. Okay? MR is the entire length. Okay? NV is this entire length. Okay? YZ is right there. ZV is this one right here. And IZ is this right here. Okay? So, like I said at the beginning, the actual work, the problems on this assignment, they're not difficult. Okay? It's basic math. It's not even algebra for the most part. Okay? But the terms, those are the keys. Remember, the intersection of medians, centroid. The intersection of perpendicular bisectors is circumcenter. The intersection of angle bisectors is the incenter. Yes, I am going to be taking pictures of this for you. You will have them on the board photos for the chapter. Okay? Be good.